Okay, so we're going to start with the fuel, which is glucose or glycogen. Glucose if it's in the blood, glycogen if it's been stored. That is a carbohydrate. That is our primary energy source. We can use fats as the source. It's our secondary energy source. It's a higher energy yield, 9 kilocalories per gram. That needs to be broken down. And it's an enzyme that breaks it down called glycolytic enzymes. They break it down and it gives us pyruvic acid. Now, if we can't get oxygen to the pyruvic acid because we need energy really quick, there's a high intensity, then that's going to become lactic acid. In the aerobic system, because the intensity is lower, we have got time to deliver oxygen in the bloodstream to the pyruvic acid. So instead of becoming lactic acid, it becomes acetyl-CoA, different substance. Now that's got the potential to create loads of energy later on. And all we'll have to do is follow a process of putting the acetyl-CoA into the Krebs cycle, where loads of different reactions take place between everything that's in there, and that will spit out 2 more ATP. We previously got 2 by breaking down the fuel with the enzymes. We've got another 2 now from the Krebs cycle. We also get a waste product of carbon dioxide, which we're going to have to breathe out at some point, the more we do this. From the Krebs cycle, we also get separate hydrogen ions and electrons. They've been separated by the Krebs cycle, and that spat them out. And with those, we can use them in another system called the electron transport chain to create 34 ATP if we started off by breaking down carbohydrate or glucose. But if we started off by breaking down fat, we can create 124 ATP. You add them together, it's either 38 ATP if we used glucose and glycogen, 34 there, 36, 38, or 124 at the very end if we used fats, plus the 2 from before where the Krebs cycle is, and 2 when we broke down the fuel with the enzymes. That's 128 ATP. So it's really good for somebody like a marathon runner because they've got a high supply of energy. They need to continue exercising for long periods of time at low intensity. And this system matches that. Okay?